Hi, good morning. Today's video we are going to evaluate this integral root square sine x over root square sine x plus root square cosine x dx, the bound from 0 pi over 2. So this one, if you take a look at here, you will see let's take, you see the bottom one, we have a square sine x and then plus root square cosine x. This one, to go through substitution here, to put, for example, u equal sine square root square sine x or root square cosine x, it's very hard to do it this way, because once you go through the differentiation, you will become another equation. Is a big long expression when you derivate. So this one, to put square root cosine x as a substitution will not work. So we have to change our idea how to solve this one. Another thing, notice another thing, let's observe here. If you put big A equal, for example, small a over a plus b, let's put big B equal b, small b over a plus small b, right? Let's add a on b. Let's make addition here. We see what's giving us here. So a plus b equal a over a plus b over a plus b. A plus b over a plus b equal 1. It's wonderful. You see, it gives us 1. So observe here, there is any connection with this form to this form. Yes, there is a connection. We see on the bottom denominator, we see a plus b, we see sine square root square sine x plus cosine x. Let's put small a is a square root of sine x, let's put b is a square root of cosine x. On the top one, this is going different, because here sine x here, the bottom as a, but b we don't have it. So let's figure out how to find out b, right? So, and then also the second thing we should know, there is a connection relationship between sine x and cosine x. What's the connection? We already know cosine x, for example, equal sine of pi over 2 minus x, right? We know that. Let's transfer this one to this one to get the combination, and then help us to solve this one. Okay, let's do it. Okay, let's begin now with our integral. So let's put substitution, for example, let's put theta x equal pi over 2 minus theta, right? Let's do the differentiation of this one, become dx equal minus d theta. Let's change the bounds, theta, theta, let's give theta, for example, x equal pi over 4, that's mean theta equal, if you give us 0 to x, okay, theta equal pi over 4, pi over 2, x equals 0. If you give x equal pi over 2, that's mean theta equals 0, right? Let's log into our integral here. So the bound become from pi over 2, 0, square root of sine x is sine pi over 2 minus theta over square sine pi over 2 minus theta plus square root of cosine pi over 2 minus t theta minus z theta, right? We don't need this one. Let's clean the board from here. So let's change the sign of the bound. It become negative 0 pi over 2 to pi over 2. Here it become negative sign. With a negative sign it gives you positive sign, which is from 0 pi over 2. Okay, what do you know about sine pi over 2 minus theta? Is a cosine theta. Okay, cosine theta, cosine theta. On the bottom one, sine pi over 2 minus theta become cosine theta. The second one, second term, becomes sine theta, sine theta, d theta. There is a connection with this one. Yes, I see almost the same, but here our I integral, this one. Now we can change the variable from theta to x or from theta to y. Is the same thing. Never gonna change the value of integral. You will not change the value of integral if you change this one from theta to x or whatever it is. Okay, because you changing the whole thing. You changing here and then you changing here as well, and then the bounds are the same. Okay, let's do it from 0 to pi over 2 cosine x over cosine x plus sine x dx. What is this? This is I. This is I2. Okay, let's put I plus I plus I, which is 2I, right? Let's put this one plus this one. It gives us d theta pi over 2 square sine x over sine x plus cosine x dx, plus the second one 0 pi over 2 cosine x over sine x plus cosine x dx. Okay, our 2I integral become one integral. Put it together from 0 pi over 2 sine x plus cosine x over sine x plus cosine x dx. Look, this one equal 1. Sine, this one is 1. So that's mean our integral becomes from 0 to pi over 2 dx, right? So our integral I equal 2I equal pi over 2 minus 0. That's mean I equal pi over 4. Okay, this is the value of this integral. Let's put it here to make it very clear. So I equal pi over 4. This is the value of integral. Okay, thank you for watching. I see you in next video.